Today we're looking at section 2.8, probability and odds. We have a couple of goals. First one is we're finding the probability of an event. Second one, we're finding the odds of an event. And in the process of doing both of those, we're going to explain the difference between the two. We begin on page 114 in the textbook with a definition, the probability of an event. Here's a long definition of it. The probability of an event is a measure of the likelihood that the event will occur due to chance. Okay, most of us are familiar with picking things at random. If you put two blues and a red in a bag and then you pull it, you know that there's a 2 out of 3 chance of getting the blue and a 1 out of 3 chance of getting the red. Everybody can kind of understand that when in terms of probability. An easy way for you to remember what probability is to call it the favorable outcome. Go ahead and add this to your definition. Favorable outcome over unfavorable outcome. And we'll actually go into that a little bit more in just a second. I'm sorry, take that back. Now I'm getting confused. It is favorable, leave the top one. Favorable over total. Favorable over total. Now we got it. Favorable over total. I'm getting confused with odds, which we'll look at in just a second. Favorable over total. Again, just like I said, you have two blues and a red from a second ago. So that's 3 things total. So 2 out of 3 chances you'll get a blue, and 1 out of 3 chances you'll get a red. That's the favorable out of the total. Outcomes are the things that actually happen. What happens when you pull one of those things out of the bag? That's the outcome. So whatever comes out, either favorable or unfavorable. And don't get those words favorable and unfavorable confused. Favorable doesn't mean good. It does not mean good. It just means what you're looking for. So the probability of somebody getting like a disease or something like that, that's not a good thing. But if you're trying to look at it in terms of outcomes, when you're looking at it in terms of probability, that would be the favorable outcome over the total. Doesn't mean good. Favorable doesn't mean good, and unfavorable doesn't mean bad. It just means not the one you're looking for. Obviously, somebody not getting the disease would be better. That'd be a good thing. But it would be unfavorable when you're talking about it in terms of what you're looking for, what you're trying to figure out why those diseases happen and stuff like that. Again, favorable outcomes, that's the thing that you're looking for. If you're flipping a coin, we know on each coin there's a heads and there's a tails. If you want to see what is the favorable outcome, let's say how many times you can get the side heads. Heads is the favorable. That doesn't mean tails is bad. It's just not what you're looking for. So favorable is the thing that you're looking for. Again, going back to the red and the blue example from a little while ago, if red was the favorable outcome, that doesn't make blue bad. It just makes blue not favorable. Theoretical probability. Now there's a thing called a theoretical, and I'll go back to it in a second, and an experimental probability. Notice they're very close to the same, the two definitions. If you flip a coin 2 times, one of those times it's going to come up heads, and one of those times it's going to come up tails. But everybody in here knows, and everybody in here has probably flipped a coin once upon a time, and you've probably flipped heads twice in a row or tails twice in a row. That's the difference between theoretical and experimental probability. We can take a coin and we can flip it, and we can flip it 10 times, and we might get 7 heads or 7 tails. That does not line up with theoretical probability. Theoretical probability is based mostly on large sums of data. If you flip that coin 200,000 times, then half of the time it's going to come up heads, and half of the time it's going to come up tails. It's not going to be, it doesn't go to chance because of that. Theoretical is what it should be. That's an easy way to remember it. Theoretical is what it should be. Based on, in this case, like if you use this example, one of them should be heads out of 2 of them because the second one would be tails. That's what it should be. Experimental probability is what it actually comes out to when it says actual experiment. Again, if you flip that coin 10 times, you might get 4 tails. Well, that doesn't line up. 4 out of 10 we know doesn't line up, that does not equal 1/2. That does not equal the theoretical probability. We know 2 goes into both of them, we'd actually get 2/5 right there, which is not equal to 1/2. So that's the difference between theoretical, is what it should be, and experimental probabilities when you actually perform an experiment. Odds, on the other hand, instead of being the favorable outcome over the total, odds are the favorable outcome over the unfavorable outcome. So if you go back to the reds and the blues thing, remember we had 1 red earlier and we had 2 blues. If you put 3 things in a bag and then you go and you pull them out random, the odds of you pulling a red are 1 to 2. You could also write that as 1 to 2. That means the same thing. The odds of you pulling a blue are 2 to 1, written as 2 to 1 or 2 to 1. Again, favorable over unfavorable. Red is not bad or good. Blue is not bad or good. It's just the one you're looking for. That's the difference, again, between probability is favorable over total. Odds are favorable over unfavorable. Okay? When all outcomes are equally likely, the probability that an event will occur is given by the formula the number of favorable outcomes over the total outcomes. That goes back just to the little quick note we made just a second ago, when they're equally likely. That means if you put 3 things at random in a bag and you pull one, there's an equal chance of you grabbing all 3 of them. Finding the probability of this event. Says there's all these stuffed animals: 12 giraffes, 3 pandas, 10 elephants, 5 horses, 21 teddy bears, 4 dogs, and 5 cats. What is the probability? You're going to get an elephant. Probability, you know you need the total of animals. So if you don't know what the total is, you need to add up all of the animals there are. And that's what we have. 12 plus 3 plus 10 plus 5 plus 21 plus 4 plus 6 gives you the number 60. So the total is 60. The question says, what is the probability you get an elephant? Therefore, your favorable outcome, we know that the favorable outcome is 10 elephants. And we know the total now is 60. So 10 over 60, favorable over total, 10 over 60 simplifies to 1 over 6, which is 0.16 repeating. When you're writing a probability, this step right here is not necessary. That's just a percentage. That just makes a percentage. When you're talking about probabilities, this is just as good. 1/6 or 1 to 6. Okay, it says using a survey to find a probability. Shows the responses of internet users from 12 to 17. That's most of you guys when asked to name their primary source of research for a school paper. And then they show a pie graph, says that 535 people use the internet, 181 the library. Library and internet equal is 30, and then 8 is other. It says, what is the experimental probability that a random chosen internet user uses the internet and the library equally for research projects? So it says, let equal use of internet and library represent the favorable outcome, and numbers surveyed represent the total number. So you have to add up all of those numbers. 535 plus 181 plus 30 plus 8. And that's how we get the number 754. That's the total. You have to add them all up. It doesn't anywhere tell us that 754 is the total. You have to find that by adding them all up. And we know that 30 people used both of them equally amount. So 30 over 754 simplifies the number. 2 goes into both of them because it's even, to 15 over 377, which is a 0.04. And if you were to make that into a percentage, again, it's not necessary. You'd move that decimal 2 spots. You would say there is a 4% chance, or only 4% of the people chose library and internet equally, or the equal amount. Notice if you look off to the left, it says the probability in example 2 is an experimental probability. because it's based on a survey. This is something that actually happened, not what should have happened. And then we mentioned this already when we were talking about the odds of an event. Odds are the favorable over the unfavorable. If you look out over to the left, it says always read as the ratio of one quantity to another. For example, 4/3 is read 4/3, not as 4/3. So you don't read it right here. This is something common for people to say 4/3. That's not the right way to write it. You read it as 4/3 or 4/3. Can also be written as 4 with a colon in the middle, 3. And then finding odds of an event, you randomly choose an integer from 0 to 9. Integers just mean numbers without decimals or partial numbers. So 0 through 9, what are the odds that an integer is even? Okay, so we have favorable outcomes, 0, 2, 4, 6, and 8. 0, 2, 4, 6, and 8. So that's 5 of them. 1, 2, 3, 4, 5. 5 of them are even, and 5 of them are not even. They're unfavorable. Again, favorable and unfavorable don't mean good and bad. It just means what are the odds that they're even. The even ones, there are 5 of them, and there are 5 that are not even. 1, 3, 5, 7, and 9. So 5 to 5, which simplifies 1 to 1. So there's a 1 to 1 chance that it'll be even. And then finding odds from probability, it says for a randomly selected U.S. trip of at least 100 miles, the probability that the principal means of transportation is a personal use vehicle is 77 to 100. It says find the odds in favor of a personal use vehicle being the principal means of transportation. The probability divided by 1 minus the probability. So you have 0.77, that's just all. In order to get 0.77, we took 777 and we divided it by 100. That's the same thing as moving a decimal over 2 spots. So that divided by 1 minus that. If you look off to the left, it says the phrase 1 minus the probability event will occur is the probability that it will not occur. So that's just the favorable over the unfavorable. So 0.77, and if you look at this, if you add 77 and 23, just if you look at it just for a second, you know that number comes up to 100. So 77 to 23 are the odds a personal vehicle is used, or 77 to 23. Again, 1 minus the probability. This is just taking probability and creating odds from it. Something that you need a couple examples, or you need a little practice to make it make a little bit better sense. The results of rolling a 6-sided number cube 100 times. So 1 to 10, 2 to 17, 3 to 15, or this is how many times, I'm reading them as 2. This is how many times 1 came up. This is how many times 2 came up. 3 came up, 4 came up, 5, and 6. It says use the results to find the experimental probability of rolling a 3. Well, we know we have to find for probability, you have to find total. Now, we are given a total from the beginning. It says they're rolled 100 times. If you want to add up 10 and 17 and 15 and 20 and 14 and 24, you'll get 100. But we know that probability means favorable over total. So at the bottom, we're going to put 100 because that's the total rolls. The favorable amount says rolling a 3. So 3 was rolled 15 times. So 15 over 100. The number 5 goes into both of them. 5 times 3 and 5 times 20. So it can be simplified to 3 over 20 as your probability. It says then find the theoretical probability. So this is what 1/6 is. We'll look at that in 1 second. 3 out of 20, that's the experimental probability. It was actually rolled that many times, and it came up 3 out of 20. On a 6-sided number cube, that's just what most of us call a regular die, everybody. It's got 6 sides on it. They come up an even amount. 1, 2, 3, 4, 5, and 6. So the theoretical probability, again, is what should it be? They should come up an even amount of times. So out of 100, you've gotten 1 out of 6. 1 out of 6 is your theoretical. This is what it should be, or the theoretical, and this is what it was based on the experiment. This is what actually happened. Then it says find the odds in favor of rolling a 3 on a 6-sided number cube. Well, we know that there's 6 options. There's 1, 2, 3, 4, 5, and 6. Those are the only 6 things that could come up if you roll a die or a 6-sided number cube. It says the favor of rolling a 3. Out of those 6 numbers, only one of them's a 3. So the favorable is 1. The unfavorable amount is not 6 because 6 is the total. The ones that are not 3 are 1, 2, 4, 5, and 6. When you count up all of those, there are 5 of them that are not the number 6. So your odds are 1 to 5, or you can write it as 1 to 5. Then it says the probability it'll rain today is 0.30. What are the odds that it'll rain today? Again, probability means favorable over total. That's probability. So 3 or 30 out of 100 is the same thing as when you move that decimal 2 spots. 30%. It says, what are the odds? The odds it's not going to rain. We know that if it's a 30% chance to rain, 70% chance it's not going to rain. So the favorable over the unfavorable would be 30 over 70, or 3 to 7, which simplifies to 3 to 7.